I am here with
Jon Stonecash from Magenic.
And yesterday you did a talk on what?
Advanced debugging.
In Visual Studio, right?
In Visual Studio 2010, but most of the techniques I talked about could be used with 2008 and 2005.
Okay. So did you use, as another question, did you use any tools other than 2010?
No, I didn't.
All in 2010?
This was basically, the only thing that I used that might not be available to most people is I used the performance analyzer, which is only available if you're in the premium and up version.
Okay.
But I showed the poor man's version. There's a little class I built that captures, you do a using statement, it's disposable, and when you start it, it starts a timer. When it disposes, it prints out something on the debug log that tells you how long it took to do this.
Oh, okay.
And it's and it's also recursive, so that you can nest this and get a real nice pattern of stuff. And I've used that to debug a lot of performance issues. You want to find out where it is, you bracket it. Oh, there's the big piece. Okay, let's bracket the smaller pieces inside and just decompose it. Kind of standard analysis. Decompose and analyze and zero in on the thing there. But all this stuff was just standard stuff you could get off the street, out of the box. And got a lot of people telling me, "Well, I learned a whole bunch of stuff." And in truth, I learned some stuff too, because I've been using this a long time. And then you bring up the breakpoint context menu, and you look, oh, there are about 6 or 7 things there. I have no idea what those are. I can do breakpoint, and I can do condition, and there's hit count, and there's when hit, and there's filter. I mean, there's a whole bunch of stuff in there that is very useful. That it's just there, and all you got to do is spend a little time to learn it.
Okay, so what are some of the debugging features that they've added in 2010 that you found very useful?
The biggest one is the ability to export your breakpoints.
Okay.
You can, if you set up a bunch of breakpoints and you're doing it in a collaborative environment, and you want to show these breakpoints to someone else,
okay,
you can sit there and try to write them out. Oh, here at this line, do this. Here you can, just export them out. They're an XML file. The other person can then import them, and all those breakpoints are there. And it was very nice for me because when I got all my breakpoints set up for my demo, I exported them out because they're very fragile. They'll go away very quick. If you just hit the wrong F9, you're dead.
Yeah.
So
that's interesting. I had no idea that it had that in there.
So that's one of the things that they added. Basically, though, the only thing that they put in there is that the premium version of the performance analyzer. They included that in.
Okay.
But basically all these things are in there, and they've been there since most of them 2005. So I was trying to make a broader thing. I was using 2010 because that's what I use in my normal day-to-day job. But almost all these things are available to people who are using any kind of version of Visual Studio since 2005.
What's the one thing you could tell a .NET Visual Studio user, developer, in terms of debugging, some things that they may want to keep in mind that they may not know of? Maybe not something tool specific, but process specific.
I guess the biggest thing is that there are an enormous number of tools that you can, in the debugger, you can look at memory, you can look at the registers, you can look, you can get right down to the metal, which for a .NET programmer is probably a little strange because they're used to working at a fairly high level of abstraction. But if you get, there are tools that will take you all the way down the metal. So one I think is most interesting is SOS, which is Sonastrike, which is a tool which you bring up. You have a breakpoint, you bring up the immediate window, you load that into your application, and now you can start saying, show me what's in memory. And this is very important because one of you can have memory leaks in .NET programs.
Yeah.
And that sounds like a little bit of an oxymoron because in a typical C program, a memory leak comes about because you have allocated some memory and then you forgot to give it back. It's on the honor system. You got it, you have to now give it back. If you forget to do that, it just sits there and there's no way to recover it. In a .NET environment, you can have a memory leak in which you have an object that has a reference you didn't know about or didn't think about, and you then get rid of the obvious reference, but that unobvious reference is still there. And typically that unobvious reference is through an event handler.
Okay. Yes.
You put in an event handler and you forget the fact that down there in that event there's actually an invocation list that points to all the people who have subscribed to this event. Mm-hmm. If they fail to unsubscribe, then it's just sitting there. And my guess is, from my experience, virtually every .NET program that's ever been written has probably got a little minor memory leak. Mm-hmm. As long as you don't have something that's iterative and long running, doesn't cause you any problems.
Yeah.
It's that when you have something like a server or something that's doing a lot of processing, creating a lot of objects, and forgetting to release those, that starts to be a problem. Which is what happened to me in my last engagement. Had this huge memory leak, and so I, by necessity, had to go out and find out how to use SOS. And it's a very powerful tool. You can go out there and say, the most powerful thing in it is, so two commands are very powerful. One is the dump heap .stat. Mm-hmm. And what it does is it will go through all of the memory that's available to the garbage collector, and will say, how many do I have of each of these types in memory, and how much memory are they using? Mm-hmm. And it sorts them from very small usage down to the bottom of the list is where you see all these largely used things. You're going to see a lot of strings down there. That's inevitable. But if you go down there and you see, oh, wait a second, I only expected to see 5 or 6 of these things down here. Now I've got 10,000.
Yeah.
Then you have a problem.
Yeah.
You can use a dump heap on that type to see all the instances of that. If you've got 10,000, that's going to be kind of painful. But if you're up against it, you're up against it.
Right.
The second command, which is really useful now, is a thing called GC root.
Oh.
Garbage collection root. And what it does is you point to one of those objects that you didn't think you should have that many of, and you say, show me who owns this.
Okay.
And what it does is it basically traces all the references up to the top level, to the root objects.
Okay.
And so that you now can look at that and see, oh, I got to go look at that code in all of its friends and see why they're not releasing things. Because it's just not a common pattern that we're used to in terms of releasing things.
Yep.
I've started to be much more careful about that because of all this problem. So
okay.
It was a fun, I learned a great deal in doing this. And this is kind of why I do code camps, is that it forces you to go out there and to learn the stuff, because you don't want to look like a complete idiot when you're up there doing your presentation. So
yeah, and it also just forces you to learn about something that you don't know a lot about.
Yes.
So okay, well, thanks, Jon.
Thank you.